Welcome to the Unit 6 presentation. Although the final project is part of Unit 6, it is a good idea to know what is around the corner and to begin working on this project as you work through the prior units. Your task is to research, design, carry out, and submit a formal lab report for an experiment that is related to this course. You must select a major concept from the list below and follow the scientific method to answer your hypothesis. You will need at least 5 resources to support your experimental process, hypothesis, or results. The lab report format should be the same formatting used in the previous units. All reports should be formatted correctly using APA style and will be checked for grammatical and spelling errors. A sample lab report is provided in this unit's information. Remember, follow the steps of the scientific method. Begin with an observation, state a hypothesis, research and design an experiment, test your hypothesis, collect your data, and conclude and reflect. You will find topics on the next page. Following the topics are considerations for the development of the topic that you choose. Try to choose a topic that is related to your professional or personal interest, and make sure that your hypothesis is well focused and testable, and that the experiment you plan to conduct can be carried out in the allotted time. Finally, make sure bias and preconceived notions do not affect what you write in your report. Here on slide 2 are the major topics. You can come back to this later, browse through the topics, and choose. The topics are also found within the assignment. Within the topic that you choose, you need to formulate a research question. It is important to make sure that your question is testable and well focused. The following examples should give you an idea of how complex and focused you need to be. The first set compares examples with different amounts of focus, from too narrowly focused to too unfocused or broad. Here is an example of a question that is too narrow. What is the rate of homelessness in Wichita, Kansas? This is too narrow because it can be answered with a statistic. Normally, you should stay away from questions that can be answered with a yes or a no. This next one is less narrow. How does homelessness affect personal health? This question is open-ended and provides an opportunity for exploration. Here is one that is the opposite extreme, unfocused and too broad. What are the effects of homelessness on children in the United States? This question is so broad that scientific research would be difficult and too extensive for a typical research paper. Here is one that is more focused. How does homelessness affect retention rate in high school students? This question is clearer. Data can be obtained and analyzed. Let's compare and contrast the next 2 questions. The first is not testable. It says, how much time do Southwestern College of Professional Studies students spend on each of their courses? This question can be answered very easily through a questionnaire, but it doesn't involve any analysis. On the other hand, the next question involves an independent variable, time spent taking courses, and a dependent variable, weight gain. It says, what is the relationship between time spent taking online courses and weight gain? The last set of examples also looks at one that is not testable and one that is. How is Southwestern College of Professional Studies addressing the physical needs of students? This question can be answered by performing interviews with students and faculty. While interesting, it is not really testable. The last one is testable. How does health and wellness differ between students that are taking classes online versus students that are taking classes in situ? The independent variable is whether students are taking classes online or in a traditional classroom setting. The dependent variable is the level of health and wellness. Once you have decided the problem you will be investigating, you should complete an all-inclusive review of scientific literature so that you can get ideas about how to approach your research using the available information and technologies. Scientific literature is made up of scholarly publications that report original empirical and theoretical work in the sciences. Review of the literature will familiarize you with studies related to your topic and about tools and technologies that can be used in your experiment. Reading studies can help you to pinpoint areas in which research is lacking or should be rethought. While you're researching, remember to collect information for citations, since you will need to cite your sources at the end of your scientific report. Organize information in an outline before you write your introduction. In the introduction, state your topic and why it's important, state your hypothesis, summarize the findings from your literature review. When setting the tone with your writing, consider the audience, the scientific community. Write in the past tense throughout your paper, since it will be read by others after completion. Your hypothesis should be stated in the introduction along with the independent and dependent variables. In the next slide, we will define hypothesis and look at some examples of hypotheses. Once you have reviewed the literature, the next step is to formulate a hypothesis. A hypothesis is an educated guess based on limited evidence and is a starting point for your investigation. You might have used or heard about null hypotheses. You may use one, but it's not required. You will need to form a hypothesis using the if-then format. Here are a couple examples. Example 1. If people become homeless, then their health will deteriorate more quickly over time than if they do not become homeless. Example 2. If students are taking classes online, then they will gain more weight than if they are taking classes on site. Notice that in the first portion of the statement, the independent variable is found, and that following the comma is the resulting dependent variable. Once you've written a hypothesis, you need to design an experiment that tests it. The procedure to test your experiment should provide sufficient detail so that one could replicate the experiment using those directions. The procedure should show a clear cause and effect relationship between an independent variable and a dependent variable. The independent variable is the variable changed by the researcher. The dependent variable is the variable affected by the independent variable. Other variables should be controlled in order to maximize the validity of the test. Remember that hypotheses are often shown to be incorrect. This is to be expected. If this occurs, then you can suggest an alternative hypothesis. Keep in mind that you need to take safety precautions too. Finally, the procedure should include descriptions and drawings of the experimental setup, if you have one, and methods for collecting reliable and valid data through rigorous testing. See more about this on the next slide. Reliability and validity. What is reliability? Reliability is the degree to which an instrument measures without change each time it is used. A test is thought to be reliable if a person scores equally on the same test each time he or she takes it. Reliability is estimated by testing and retesting, or by checking for internal consistency by grouping questions that measure the same concept. What is validity? Validity is the strength of one's conclusions. It indicates the accuracy with which the test measures what it's supposed to. A simple example of validity and reliability is an alarm clock that rings at 7 o'clock each morning but is set for 6:30. It is very reliable because it consistently rings the same time each day, but it is not valid because it is not ringing at the desired time. Here are a few types of validity. External validity, also known as sampling validity, is the extent to which the results of a study can be generalized from a sample to a population. In order to establish sampling validity, you have to have a sample that represents the population. Another type of validity is construct validity. It refers to the appropriateness of the instrument's content. In other words, do the measures, such as questions, do they accurately assess what you want to know? Next, face validity is basically it ascertains that the measure appears to be assessing the intended construct under study. An example is that if a measure of art appreciation is created, all of the items should be related to the different components and types of art. If it doesn't, the stakeholders may not be motivated to give their best effort or invest in this measure because they do not believe it is a true assessment of art appreciation. Once the procedure is written, it is time to follow it. So get your materials and begin the experiment. Efforts should be taken very seriously to ensure that you take exact measurements and record your data accurately. Make sure to only introduce one independent variable. Any confounding variables will compromise the validity of the experiment. And please follow safety precautions. Once you have collected all the data, you will analyze it. There are two types of data with which you will likely work, quantitative and qualitative. Quantitative data is collected as or is translated into numbers, which can be analyzed mathematically, for example, by calculating the mean. Qualitative data are collected as descriptions, opinions, and other non-numerical information that has to be analyzed in another way. There are strengths and weaknesses to each type of data. As an example, hard data from a test may be able to measure the mastery of a concept. However, it does not measure the look of relief, dismay, or pride on a person's face after seeing the grade, while qualitative data can. All data can be affected by the way the researcher sees the world, so make sure to be impartial as you interpret your data. You should include a data table showing raw data from all your trials, text in paragraph form with information about your data and trends, charts and/or graphs that best display trends and data. Make sure to include chart and graph titles, headings for axes and units. You must decide which type of graph or chart works best for the data collected. Consider the information on the image of the next slide. This diagram can assist you in deciding what table, chart, diagram, or graph best suits your analytical needs. Consider the following example. You have obtained quantitative data on how compliments affect student behavior. You are comparing two methods for giving compliments: through verbal praise using your own voice and using a computer-generated audio-visual recognition system. The behavior has been quantified by tallying the number of students that mimic the behavior once they have seen it complimented for each of the two methods. We start at the center of the diagram. When we're using this image or this diagram, we start at the middle where it says, "What would you like to show?" It is clear that I am making a comparison between the outcomes for two different methods. Since the feedback is not changing, I can use a bar graph. Once you've finished your analysis, you're ready to wrap up your work. Your conclusion should restate the topic and should state whether or not the hypothesis was correct. Also, you should summarize the introduction and your findings and discuss the broader implications of your findings. You should mention the limitations of your research attributable to its scope or weaknesses, including error if any was understood. Additionally, you should explore possible alternative hypotheses if yours was incorrect, and you can suggest other avenues for research. Following your conclusion is your reference page. The last thing you will write is your abstract. Even though it is written last, it is placed at the beginning of the scientific paper because by reading it, one can decide whether or not to read the entire document. The abstract states the objectives and scope of the work, describes the procedure used, and summarizes the results and conclusions. For it, you will write a short summary of the entire paper. A good rule is to write 1 or 2 sentences for each of the main parts of the paper: the introduction, procedure, results, and conclusion. Make sure to state your hypothesis and whether or not it was correct. Limit your abstract to about half a page of text or about 150 words. Once you've finished writing your report, you should have fellow scientists review your work and submit it for publication for further sharing. Congratulations. And you're well on your beginning your project now.